Welcome to the Deep Dive. Today, we're tackling one of the most debated foods out there, soybeans.
And specifically, we're focusing on its fermented superstar cousin, Tempeh.
Exactly. We've got a whole stack of research here. We're talking high-quality meta-analyses, systematic reviews, randomized controlled trials, the works.
Right. And the goal for this deep dive is to bring some real clarity. Soy is just a minefield of claims and confusion, especially around phytoestrogens.
So our mission is to cut through that noise.
Yes, we're going straight to the gold standard studies to find out what the medically supported benefits are, what dosages actually work, and just as important, the safety precautions you really need to know.
And we're going to start with what seems to be the single biggest takeaway from all this research. Tempeh basically solves soy's biggest problem.
Its biggest problem is bioavailability. Absolutely.
Okay, so what does that mean? If you only remember one thing from this conversation, why should it be about fermentation?
Well, to understand why tempeh is often so much better than, say, soy milk or plain tofu, you have to look at the chemistry. It's all about these compounds called isoflavones.
Right, the things everyone talks about with soy. What are they doing inside the raw soybean?
In unfermented soy, these isoflavones are essentially, they're sugar-bound. The technical term is glycosides.
Glycosides.
Think of it like an active ingredient wearing a really thick, heavy jacket made of sugar.
Okay.
It's just hard for your body to absorb something when it's wearing a jacket,
Yeah.
Especially if your gut isn't really set up to take that jacket off.
So even if a food label says it has a lot of isoflavones, you might not actually be getting the full benefit. It just passes right through you.
Precisely. But this is where tempeh comes in. The fermentation process uses the Rhizopus fungi.
Okay.
And this culture acts like a little biological key or maybe a cleaver. It just strips that sugar jacket right off.
So it's unlocking the compound.
It is. It converts those bound glycosides into their free, unbound forms. We call those aglycones.
Aglycones. And the main ones are?
Genistein and daidzein. Those are the heavy hitters.
And is the difference in absorption really that big a deal?
Oh, it's huge. The studies show that when you eat tempeh, which is rich in these aglycones, you absorb them 2 to 3 times more efficiently.
2 to 3 times?
Yeah.
Wow.
Yeah. And that leads to much higher concentrations of the good stuff actually circulating in your bloodstream. Tempeh is, it's basically a pre-digested, supercharged delivery system.
That's incredible. So it's not about what's in the food, it's about what your body can actually get out of it.
That's the whole game.
Does this fermentation process do anything else? Does it optimize other parts of the soybean?
Oh, definitely. It also tackles what we call anti-nutrients.
Anti-nutrients.
Sounds bad, right?
Yeah.
Unprocessed soybeans have things called trypsin inhibitors, and they interfere with how you digest protein.
Okay, so they get in the way.
They do. But fermentation just eradicates them. So the protein quality and digestibility of tempeh is significantly higher from the start.
And I think I saw something about phytic acid in the sources.
Yes, that's the other big one. Phytic acid gets reduced by a huge amount, anywhere from 30 to 65%.
And why does that matter?
Because phytic acid binds to important minerals like iron, zinc, calcium, and it blocks your body from absorbing them. So by breaking down that phytic acid, tempeh actually boosts the bioavailability of all those key minerals. The food just becomes fundamentally more nutritious.
So you're getting better protein, better minerals, and better absorption of the isoflavones.
Yeah.
That's a powerful combination.
And there are bonuses. Tempeh is also a great source of vitamin K2.
The MK7 version, right?
The highly desirable MK7 variant, yeah. Usually around 20 to 50 micrograms per 100 grams. And for anyone on a plant-based diet, it also has measurable amounts of vitamin B12, which can be hard to find.
That's a huge win. Let's switch gears to the gut. The sources mentioned Tempeh's effect on the microbiome is pretty unique.
This is a really exciting area, though it's still emerging. So even after you cook tempeh, it delivers what are called paraprobiotics.
Paraprobiotic?
Yeah, they're basically beneficial bits and pieces from the heat-killed fungi, plus all that good fermentable fiber.
And this actually changes your gut bacteria.
Human studies have shown it does. Eating tempeh consistently increases beneficial gut bacteria, like Akkermansia mucinifera.
Akkermansia. That's the one you always hear about for gut barrier health and metabolism.
The very one. And the studies also show it boosts secretory IgA, which is critical for your gut's immune system. It's a true gut modulator.
Now, you mentioned something earlier, the Equol factor. The idea that some people benefit more from soy than others.
Right.
If only, 30 to 50% of Westerners are Equol producers, doesn't that make soy kind of a genetic lottery?
That has been the challenge for decades. It explains so much of the mixed results in older studies. If you're not an equal producer, you just don't process the isoflavones as well.
Which is why one person swears it helps their hot flashes, and their friends see zero effect.
Exactly. But here's the crucial point about Tempeh. Because Tempeh delivers the active ingredients already in that highly absorbable ag-glycone form, it helps maximize the benefits for everyone.
Regardless of whether you're an equal producer or not.
Precisely. Tempeh sort of levels the playing field. It offers a universal advantage.
That is a phenomenal insight. Okay, so Tempeh is a better delivery system. Let's see if that translates to real health outcomes. We'll start with the highest quality evidence, cardiovascular health.
Right.
What do the trials say about soy protein and cholesterol?
The evidence here is solid, moderate to high grade. The consensus is that consistently eating about 25 grams of soy protein a day leads to a modest but very repeatable reduction in LDL cholesterol.
Okay, let's talk about that modest part. The drop is only around 5%, right? Something like 4.8 to 6.9 milligrams per deciliter.
That's right.
Is
Yeah.
that actually meaningful? Or is it just, statistically significant noise?
That is such a great question. Because no, a 5% drop by itself isn't a game changer like a statin. But it's incredibly reliable across different groups of people. And heart health is a game of cumulative risk. A reliable 5% reduction, maintained over decades, that is absolutely meaningful for your lifetime cardiovascular risk.
So it's not a hammer, it's a steady dietary influence.
Exactly. And the mechanism is twofold. First, you're usually swapping out higher cholesterol animal proteins. That's a simple displacement effect.
Sure.
But second, the isoflavones and peptides actually tell your liver to upregulate its LDL receptors. It enhances your liver's ability to pull that bad cholesterol out of your blood.
Okay, so that 25 grams of soy protein, how much tempeh is that for someone at home?
It's roughly 1 to 2 standard servings, so about 125 to 250 grams of tempeh a day.
And what about blood pressure?
Here we have moderate evidence. Soy consumption does help, especially for people who already have hypertension or metabolic syndrome.
And what are the numbers there?
You see reductions in the top number, the systolic,
Yeah.
by about 2.5 to 3.2 millimilli-Hg, and the bottom number, diastolic, by about 1.5 millimilli-Hg.
Again, small but consistent effects that add up. Better cholesterol, lower blood pressure. The whole picture starts to look better.
It really does. And when you look at the big observational studies, people with higher soy intake have about a 13% lower risk of cardiovascular disease events.
And I saw a link to type 2 diabetes as well.
A strong one. About a 17% lower risk of developing it. The clinical trials back this up, showing small but real improvements in fasting glucose and insulin sensitivity.
Okay, let's transition to some more targeted benefits. A big one is menopause. What's the verdict on soy for hot flashes?
The evidence is moderate and quite robust. Isoflavones, at a dose of about 50 to 90 milligrams a day, are clearly effective.
At reducing frequency and severity.
Both. Studies show frequency can drop by up to 20% compared to a placebo. And it's not immediate. You need to be consistent for about 6 to 12 weeks to really see the effect.
And this is where being an equal producer gives you an extra edge.
A big edge. They often report even greater relief.
What about bone health? That's another major concern, especially for postmenopausal women.
Moderate evidence here, too. Soy interventions with at least 90 milligrams of isoflavones daily for 6 months or more show small but significant improvements in bone mineral density.
Especially in the lower back.
Yes, particularly in the lumbar spine. And they also reduce markers that show bone is being broken down. So you're preserving bone mass.
And we talked about tempeh and mineral absorption earlier. That must play a role here.
A huge role. There are studies confirming that the calcium you get from tempeh is absorbed just as well as the calcium from cow's milk. It's a fantastic food for skeletal health.
Okay, let's talk about the big one. Cancer. This has caused so much fear around soy. What does the best evidence say today about risk?
The consensus now is overwhelmingly positive and protective. Higher lifetime soy intake is linked to about a 13% lower risk of breast cancer.
And for men and prostate cancer.
The link is even stronger there, about a 26% reduced risk of prostate cancer, and the benefit is greatest for people eating fermented soy.
That's a big deal. But what about for people who are already breast cancer survivors? Is it safe?
Yes, absolutely. This is so important. Multiple large studies confirm that for survivors, eating soy is associated with a lower risk of recurrence and mortality.
So a reduction of about 16%.
That's right. The message is clear. Soy is safe and likely beneficial for survivors.
Now, for the other hormonal myth, the one that just won't die, does soy lower testosterone in men?
It does not. The data is unequivocal.
How do we know that so definitively?
Because researchers pooled the data from 41 separate clinical trials into massive meta-analyses. The conclusion: zero adverse effect of soy or isoflavones on testosterone or estrogen levels in adult men. The myth is just not supported by the science.
That's very clear. Okay, one last area before we get to takeaways: Tempeh and the brain. The evidence is early, but it looks interesting.
It's very interesting. This is a low evidence but high potential area. Some small but promising trials out of Indonesia looked specifically at Tempeh.
And what did they find?
They found that older adults with mild cognitive impairment who ate 100 grams of Tempeh a day for 6 months actually reported measurable improvements in their global cognitive scores.
And what's the theory? Why Tempeh?
The hypothesis is that it's driven by the unique byproducts of fermentation and its powerful effect on the gut. It really points to a strong gut-brain axis connection, but
we need more research.
we definitely need more research, but it's a fascinating start.
Okay, let's put this all together into some actionable advice. If someone wants these benefits, what are the effective doses we're talking about?
Well, first, prioritize Tempeh. It's just the superior form for all the reasons we've discussed.
Got it.
For heart health, the LDL and blood pressure benefits, you're aiming for 25 to 50 grams of soy protein daily.
Which is that 125 to 250 grams of Tempeh, 1 to 2 servings.
Exactly.
And for menopausal symptoms.
There, you're targeting the isoflavone content, so 50 to 90 milligrams daily. And for that experimental cognitive boost, the dose was 100 grams of Tempeh daily.
And consistency is everything.
It's absolutely key.
Okay, finally, the critical safety checks. What are the major medication interactions people need to be aware of?
There are 3 main ones to watch if you're starting a high, consistent soy intake. First is thyroid medication, like levothyroxine.
This one comes up a lot.
It does. Soy can interfere with its absorption. The fix is simple. Just separate them, take your medication at least 4 hours away from when you eat soy, and maybe have your doctor check your TSH levels.
What about blood thinners like warfarin?
So fermented soy, especially tempeh, is rich in vitamin K2, which helps blood clot. This can work against warfarin.
So you should stop eating it?
No, not at all. The key is consistency. Don't suddenly start or stop eating a lot of it. If you do make a big change, just tell your clinician so they can monitor your INR and adjust your dose if needed. Communication is key.
And the third one
is for older antidepressants, the MAO inhibitors. Fermented foods have tyramine, and at high doses, it can cause a hypertensive crisis for people on those specific drugs. So moderation under 100 grams a day is advised.
But for the general population?
For almost everyone, 1 to 3 servings of soy a day is extremely safe.
This has been incredibly helpful. So to recap the strongest points, soy protein reliably lowers LDL. Isoflavones help with hot flashes and bone health in postmenopausal women. And the start of the show is tempeh, because fermentation just makes everything work better.
Exactly. And that brings us to the final thought to leave you with. For years, the question was why Asian populations seem to get more benefit from soy than Western populations.
And the answer was always chalked up to genetics, that equal producer gap.
Right. But what if the answer wasn't just genetics, but also preparation? Tempeh, by converting those isoflavones into aglycones before you even eat it, essentially maximizes the potential benefits for everyone.
So it helps bridge that genetic gap.
It does. It gives everyone access to that more bioavailable form. We're sort of moving past the limitations of genetics and into the world of optimization through food science. And where that leads next, especially with the gut-brain axis, well, that's the next great frontier.